All right, so I'm Karl. I'm an investor, and I work on a site called agingbiotech.info. This is a summary of the whole field. These slides are dense. I'll put this URL and this QR code up at the end on the last slide too. But if you want to follow along, go ahead and scan that. Today, I'm going to go through some background super fast because we all know this stuff. We don't really need the motivation. We have plenty of talks on that. You know, in 1900. A lot of diseases weren't age-related, the top killers, and we've largely eliminated some of the infectious diseases that used to be top killers. The thing I want to call your attention to on the background here is that, you know, the way medicine usually works, even before the aging field, is we have obvious disease, we figure out some of the biology in that so we can interfere with it. Sometimes we figure out earlier causal chains, and over time in the last several decades, we've figured out those earlier causal chains as we backward chained. We've hit some things that actually, it turns out, are on the causal chain for multiple different age-related diseases, and we call this the geroscience hypothesis. And we think that if we interfere with some of these things that are back at far in the causal chains and that underlie multiple age-related diseases, that by interfering with those things, we can mitigate multiple age-related diseases at the same time. And that's sort of the North Star of the field. So that's super important. We all know the field is under-resourced. There's a preprint up that you can read that's sort of a justification summary of the whole field, my view. It's in an upcoming book chapter. One thing I want to focus on here is some terminology is actually important. A lot of people label the field aging. A lot of people label the field longevity. Aging is the pathology, and that leads to death and shorter lifespans and poor health. Longevity is the side effect of treating that pathology, and you know, there's a well-known psychological phenomenon that loss aversion is stronger than gain for the same difference. So, you know, if you look at cancer, cancer is a field that gets a lot of resources, and nobody questions the utility or the value to society of curing cancer. If you look, you know, cancer is the pathology. The analogous word in our field is aging. We have the hallmarks of cancer paper. We have the hallmarks of aging paper. We have the National Cancer Institute, the National Institute on Aging. The common vernacular for the field, though, is cancer for cancer and longevity for longevity. So the common label is effectively the pathology in the case of cancer, but it's, for some reason, it's the side effect of treating the pathology in the case of the aging and longevity field. And you know, cancer gets a lot of funding because you're curing this problem, is the loss aversion. Longevity doesn't get nearly as much funding. It's viewed as sort of greedy to want more stuff. So I think that the field would maybe be better focusing more on aging. You want to focus on the pathology, that geroscience hypothesis, the fact that we're treating underlying pathologies. And so the rest of this talk is going to be about that. Over the last year, I've given talks at several conferences, including here last year, about the fact that treatments that really do embody the geroscience hypothesis, that really do treat these shared upstream in the causal chain pathologies that underlie multiple diseases, they are making their way through therapies. You'll hear people at conferences, we've already heard it yesterday, at least once, say things like, there are 0 FDA-approved aging treatments. That's just not true. There's 0 FDA-approved treatments that have been proven beyond a doubt to extend human lifespan, but there are treatments that treat fundamental aspects of aging that are FDA-approved. So look at this talk. There's a version from this conference last year, or a more recent version from half a year ago at the Buck. And you know, I run this website. If you don't know that, I'm going to assume most people here know it. If you don't know it, you should check it out. This is the sort of summary. There's a handful of approvals. There's more coming. They're in phase 3. The whole pipeline has got stuff in it. And this is important because these really do embody the mechanisms of action of these therapies really do embody the geroscience hypothesis. They really are, there are reasons to believe that they will mitigate multiple different age-related diseases. Okay, so, and that's important and it should be discussed more in the field. So what I want to concentrate on in this talk today is that there really are two different subfields here within the overall aging and longevity field, and it's not often enough discussed, the differences between these two, or even the recognition that the divide and conquer rejuvenation one exists. The two main broad subfields are broadly slowing aging, which essentially broadly slows all the aging sub-related pathologies because it essentially slows the whole clock. So all the different sub-pathologies of aging are slowed to a certain extent. Or divide and conquer rejuvenation, which Aubrey pioneered in the 2000s, which is figure out each of the individual sub-pathologies and really fix it. Do a really, more than a modest job of slowing it by a certain, much less than 50%. And then there's a sort of a third distant cousin, which we hear about a lot at this conference, which is replacement or whole body replacement specifically. And though that's got a high presence specifically today and yesterday at this conference, it's actually very, very little discussed within the overall aging and longevity field. The dominant subfield is the broadly slowing aging. That's what Eric Verdin talked about. He's the head of the buck. That's what Nir Barzilai talks about. That's for the most part what Matt Kaberlein talks about. That's what the top people in the field are constantly talking about, is broadly slowing aging. But this actually happens. The divide and conquer rejuvenation is being embodied by several different programs. But what doesn't happen is people actually talking about it as a high-level approach to the field and explaining that their programs fit within such a program. I've been investing in the field for 8 years now, and I exclusively invest in divide and conquer rejuvenation, though I cover the whole field on agingbiotech.info. And I've been embodying some litmus tests that I use to judge whether or not something is part of the divide and conquer rejuvenation field versus broadly aging. And I've realized over the last few months that I never really operationalized that well enough to communicate to other people. And there's some things that even Aubrey's explanations have only kind of implicitly hit at, and he doesn't concentrate on enough. And so I want to talk about some of those. This is the sort of brief table, right? So the obvious high level is the broadly slowing hits most or all the aging subpathologies, and the divide and conquer rejuvenation are mostly these very specific individual subpathology targeted things. But what are some of the other implications? For the most part, the broadly slowing effect sizes are less than 50%, well less than 50% of lifespan. They're usually less than 50% in mice, and they're even worse in people generally. So they might slow it by 5 or 10 or 15 or 25% if we're lucky in humans. But some other litmus tests are the broadly slowing approaches. Generally, the target is a process, whereas the divide and conquer damage repair style rejuvenation approaches, the target is a stable molecular structure. And so that's a very clear distinction that hardly anybody ever discusses in the field. mTOR is a process. AMPK is a process. The whole complicated ball of metabolism that most interventions that actually can be proven to extend lifespan by themselves are hitting these processes. Whereas long-lived senescent cells are a structure. Long-lived, stable, misfolded proteins are a structure. So there's a whole bunch of these structures. So I'm gonna go over each one of these in a little more detail. The last one I'm not going to talk about too much in this talk, but whether or not you have to dose the therapy continually versus intermittently and infrequently, like you would, for example, with a senolytic, which could then be not given for several years while the slow accumulation of long-lived senescent cells build up again. So the most important distinction is the part versus the whole, right? Which is the goal, to slow everything or just to fix a part? And this gets back to the whole aging versus longevity. The slow everything can buy you some actual longevity gains in a single therapy, but aging is the thing that's treating the pathology. So this gets at the issue of what counts as an aging drug or what counts as a longevity drug. And in my opinion, the litmus test is the geroscience hypothesis. Does it treat one of these core aging areas? But a lot of people treat the litmus test as, does it extend lifespan? If it doesn't extend lifespan, it's not part of our field. I think that's a terrible litmus test. And you can see this what counts as a longevity drug thread for a lot more details. All the threads, if you load the slides, all the threads are live, or all the links are live, and you can click through to more detailed material. So I think that we eventually need, the important thing is that there's all these different subpathologies, and we eventually need treatments for all of them. And so that's a good way to measure progress rather than just the litmus test of lifespan extension as we go. So the difference between targeting a structure versus targeting a process is essentially this slide that Aubrey and the SENS crowd have been talking about for years, but I'm going to take the basic slide. I changed a little of the stuff, and I put damage repair instead of maintenance on the middle part there. But you know, metabolism is this ball of processes that have as its side effect all the different damages of aging, but they create stable structural problems that are then further pathological. And so sort of in the process versus structure terminology, the parts of Aubrey's slide that where damage versus metabolism, the metabolism is the process, the damage is the structure. And for the most part, you know, the gerontology approach is the broadly slowing aging approach, which dominates the conversation. So one thing that the field has unfortunately been terrible about doing is you know, it's got the 7 SENS areas, and it's got the hallmarks of aging paper and the little known pillars of aging paper, and hardly anybody ever actually reconciles them. So here's a mapping between the SENS areas and the hallmarks of aging. But more importantly, this is the set that are based on stable structures, and this is the set that are based on processes. There's very clear mapping here. What's interesting is if you look at what actually, you know, people talk about the hallmarks of aging and there's science on them, but then if you look at what actually happens in some of the field, I'm going to shift these around, you know, all of the top 10 ITP, interventions testing program results that extend lifespan the most, all hit the areas that are process. And Nir Barzilai has been talking with some co-authors about a way to rank repurposable drugs that might be good for aging and longevity, and based on their ranking, 11 of the 12 are all things that target processes. Only one weak senolytic makes the structure cut. So let's say what are the different, so we can take the sort of basic SENS kind of structure list plus some other ones that were less obvious when SENS was originally proposed, and we can drill down and we can say, okay, well look, what are the stable structural problems for each one of these? So for example, misfolded proteins, we have a bunch of different kinds of misfolded proteins, alpha-synuclein and tau and ATTR. There's different kinds of senescent cells. The extracellular matrix has various different kinds of problems. The mitochondria have various different kinds of problems. There's different kinds of cell loss and atrophy. And each one of these affects multiple different kinds of diseases, truly embodying the geroscience hypothesis. So we can take that, so this is the sort of, you know, high-level category, subcategory. Now let's drill down. So, you know, normally, so what I want to look at now is the aggregate pipeline of what's actually happening in the biotech sector with respect to these different stable structural subpathologies. So normally, when you have a single company and you did a pipeline slide, you would have a list of targets, and then you would have this bar chart with arrows or lines of what clinical stage you were at, and maybe it would list the indication as well. When you do an aggregate pipeline across all the companies in a whole industry, that gets too long to scroll for slides. So here's the target category. Here's the sort of main category here. Here's some super categories, which we can talk about. And then instead of like drilling down in a horizontal tree, in order to fit everything on one slide, I've taken after the subcategory, after the main category, I've got the subcategories up here. And then we've got all the different individual subpathologies filling out the table. And then instead of bars going across, we can just do color coding. So this is my investment portfolio organized according to the different stable structural subpathologies of aging and their subcategories. So it's going to be hard to look at this, and the details aren't so important as to sort of look at the colors. Let me walk you through the color key. Green are things that are already approved. Phase 3 is blue. Don't see any of either of those colors on my portfolio yet. Phase 2 is in purple, so I've got a couple in purple. Rubido's up here with its senolytic, and Immunis is down here with its cell loss for muscle atrophy. And then phase 1 is in yellow. Orange is preclinical. Red are companies that have failed, but the science is still valid. They failed for business reasons or financing. And there's a couple companies that are about to spin out that I am involved in, but haven't officially invested in. So this is just my portfolio. We need more investors. I invest exclusively trying to fill up this table. We need more investors to do that, or to at least be devoted to trying to pick points on this table, because there aren't enough in the field. Okay, so that's just one investor over 8 years who's not a billionaire, and I've managed to do this. But it's not a lot. You know, each one of these only has a small chance of success. This is the aggregate pipeline of the entire set of aging-focused companies. So this doesn't include veterinary, this doesn't include supplements, and this doesn't include the programs that hit some of these targets, but are from companies that aren't, for the most part, focused on aging. So like a big pharma program that happens to hit one of these, or other companies whose focus is oncology or something else but have a side program. But this is only the clinical stage. So I've only done the yellow, purple, blue, and green. We have Mesoblasts approved in Korea and just announced this week a successful phase 3 in Japan, stem cell therapy for cartilage loss and osteoarthritic knees. But for the most part, not a lot of approvals yet, but a good amount of stuff in the pipeline. Now, this is what it looks like if we add in the preclinical stuff. Now, this is not exhaustive. This isn't every single preclinical program. That's much harder to count those, but I wanted to hit a bunch of ones that don't have the clinical stage. And then the gray boxes are things where there's not really anything. But the problem is, of course, this is both an underestimate because it doesn't hit a lot of those things, but it's also you know, optimistic the other way because it doesn't have all the damage types. And then, of course, many of these are going to fail. So it's working. We're getting things through that really are targeting stable molecular structural pathologies of aging, but it's not fast enough, and so we need more. And then what's particularly poor is the diagnostics that specifically hit these things. There's a lot of things where we don't know. You know, we don't have a good way to measure senolytics clinically, or senescent cell accumulated burden clinically to sort of judge things. My portfolio has only one thing in here, which is a technique for doing measurement of misfolded proteins from a company called Amprion. So things that broadly slow aging, anything's useful if it helps bring more resources to the field. And a lot of the stuff that broadly slows aging, I don't think will get us long-term radical health span extension. But it will help, as will anything else on this list, if it helps unlock a lot more funding for the field. And so the things in the orange arrows are, this is a table on agingbiotech.info called Convincers, and a lot of the orange arrows are things that include broadly slow aging approaches. But this is the sort of main trade-offs slide of the talk. You know, here's the trade-off between broadly slowing all aspects of aging versus targeted reversal of stable structural molecular damage, the sub-pathologies. For the most part, modern lifestyle has accelerated the aging of people over the last 50 to 100 years through obesity and inactivity, and a lot of the that has broadly accelerated. It's sort of the opposite of broadly slowing aging. It's broadly sped up aging and accelerated all aging-related pathologies in a large fraction of the population. A lot of the broadly slowing targets help reverse that, and that's a huge overall society-level health improvement because of how bad the age acceleration is, 42% obesity in the US, for example. But the trade-off is that the slow aging approaches, though they hit all the different things, their effect sizes are just not very large. Whereas the divide and conquer rejuvenation is the default path if we want to go to fully eliminating aging. If we want to do to aging the same thing that was done to some of the infectious diseases that were top killers hundreds of years ago, which was fanciful at the time, maybe, but and so to some people it still seems fanciful to go that far with aging now. So that those kind of age reversal damage repair style therapies can basically almost fully eliminate, if not fully eliminate, that sub-pathology, but that doesn't necessarily, you know, extend lifespan by itself. So how should the field divide its resources between these two? At the very least, it should be talking more consciously at the top level of the field about this trade-off and about these things, and that discussion almost never takes place. So why are you hearing this message from me? you should be hearing this from much more important people than me, and this is a big problem in the field. Some people don't even recognize these things. You hear people say things like progress in the field should be measured by the ITP results. You hear people saying that the field isn't progressing because nobody has beaten calorie restriction in the last 50 years. Those things are just narrow-minded views that are only looking at the broadly slowing aging half of the field and essentially ignoring the whole divide and conquer rejuvenation approach. And there's a lot of money in mitigating those modern lifestyle age accelerators. There's a lot of money in obesity. And even the companies that are doing things that target stable structural aging pathologies, the large gravitational pull of all that money in metabolism and diabetes and obesity is causing many of the programs in those companies to sort of nudge in the direction of treating metabolism rather than treating the stable molecular structures. And that's not really a criticism of those companies. If they could take that money and use it to develop these programs further, that's great. But in some ways, it's there's a lament there about how distorting that effect is. So that's it. I'm happy to take questions if there's any time remaining. And at 4 o'clock in one of the side rooms, I think this building, I'll go into more detail and do questions for as long as people want. And we can go over any of the slides I skipped. But the take-homes to remember are that broadly slowing aging by divide and conquer rejuvenation are really both valid subfields, and we can't forget the latter one. And that targeting processes versus structures is a key distinguisher that not enough people explicitly talk about in the field, as is the distinction between continual dosing and infrequently intermittent dosing. And the other thing is that aggregate pipeline, some of them will fail, but a lot of them are going to succeed, and we just don't at this point know how good that's going to be. We have no idea where that's going to get us on the way to LEV. It's inappropriate for some people to say that approach to the field has failed. We absolutely hasn't failed. It hasn't even fermented enough or come to fruition enough yet at all, and time will tell. But it's going to be 5 years before many of those things are through in humans. And then, we can talk in questions that people want about pets. Aubrey's on the way to, with LEVF, on the way to getting some estimates about how this stuff can combine in mice. But even there, the first experiment didn't tell us much, and we won't know for a while until the second experiment. So we don't even have really good estimates for how much the overall effect size accumulates as we build up a substantial number of these things. All right, that's it.